Hey everyone, today we're diving into a concept that's, well, kind of at the heart of everything, from your Netflix queue all the way to clinical drug trials. We're talking about variance. Now, I know, it sounds a little technical, but I promise, by the end of this, you're going to start seeing it absolutely everywhere. And a huge thanks to Stat Harbor Analytics for making this explainer possible.
All right, let's kick things off with a question. Have you ever been scrolling through your streaming service, which is supposed to know you inside and out, and it suddenly recommends a movie you would absolutely positively hate? Or, you check a weather app that promises a beautiful sunny day, only to get completely soaked in a downpour? Yeah, we've all been there.
Well, a lot of the time, the answer to why comes down to this fundamental tug-of-war in machine learning called the bias-variance trade-off. See, a model with high bias is just too simple. It completely misses the real pattern. We call that underfitting. But a model with high variance, that's the total opposite. It's so complex and so sensitive that it learns all the random noise in the data it was trained on instead of the actual signal. That's called overfitting. And to really get why that sensitivity is such a massive problem, we need to get a handle on what variance actually is.
So to really tackle that whole overfitting thing, we've got to zoom in first. We need to understand the core concept itself. So let's ask the big question. What exactly is variance?
Okay, I know what you're thinking. You see a formula like this, and your eyes just might start to glaze over. The formal definition is the expected square deviation of a random variable from its mean. But seriously, don't let the fancy words throw you off. All this is really asking is, on average, how far is each point in our data from the group's center? That's it. It's a measure of spread.
In fact, let's just toss the formal definition out the window for a second. At its very core, variance is about one thing. It's a measure of spread. That's the key word. It tells you how spread out or how unpredictable your data is. Are all the numbers huddled together, nice and cozy, or are they just all over the map? And this picture just illustrates it perfectly. Check out these two sets of scores. Now, here's the wild part. They both have the exact same average, a perfect 10. But look at them. They tell completely different stories, right? The low variance group on the left is super consistent, very predictable. But that high variance group on the right, it's all over the place. Same average, but a totally different reality. That is variance in action. Okay, so variance measures spread. But how does that spread actually behave when we start, messing with the data? Let's take a look at a few super simple but really important rules. So what if we just shift our data? Let's say we add 5 points to every single score. As you can see, that doesn't change the spread one bit. The variance stays the same. But what if we scale it? Say we multiply every score by 2. Well, that's different. The variance actually scales up by that number squared. And finally, the easy one. What about just a single constant number, like 7? Well, a single number has no spread at all, so its variance is just 0. Simple as that. All right, enough theory. That's all cool, but where does this stuff actually matter? Let's jump from these abstract rules to the real world, to practical decisions, where understanding variance is, frankly, everything.
I mean, think about this for a second. How on earth do political pollsters get a reliable read on an entire country of millions by just talking to 1,000 people? How can they be so confident about their margin of error? It seems kind of crazy, right?
Well, the secret sauce is how they sample. You see, on the left, you could sample with replacement. That's like pulling a name from a hat, writing it down, and then putting the name back in. Every single draw is totally independent, but that's not what pollsters do. They sample without replacement. Once they talk to someone, that person is out of the pool for good. Every person they talk to slightly changes who's left, which actually reduces the overall uncertainty. And you have to account for that to get an accurate result.
And here is the real kicker. The amount of variance in the population you're studying directly tells you how big your sample needs to be. Think about it. If you're studying a group where opinions are all over the place, that's high variance, you're going to need a much bigger sample to get a good read. But if the group is pretty uniform, low variance, you can get away with a much smaller sample. It's all about the spread.
And honestly, its role is even bigger than just polling. Variance is literally the engine that drives almost all of modern science. It's the key ingredient that determines the power of a clinical trial for a new drug, how wide a confidence interval is, and the value of pretty much every test statistics scientists use to make groundbreaking discoveries.
So, wow, we've gone all the way from terrible AI recommendations to political polls to the heart of scientific discovery. Let's pull this all together. Why is this one idea, variance,
one of the most important concepts in all of data.
Because at the end of the day, variance isn't just some number you calculate on a spreadsheet. No way. It's the bedrock for making smart, informed decisions with data. It tells us exactly how to design our experiments. It's the critical dial we have to tune to fix those bad AI recommendations we started with. And it is the universal language for measuring risk and uncertainty, everywhere from Wall Street to your doctor's office.
You know, this quote from the material we looked at just nails it. Variance is not just a descriptive statistic, it is central to inference, learning, and decision-making. It's not a side character, it's the main event.
So ultimately, variance is so much more than just math. It's our best tool for measuring unpredictability itself. It's the caliper we use to get a firm grip on the chaos of the world. So the question I'll leave you with is this: what uncertainty will you go out and measure next? This explainer was brought to you by StatHarbor Analytics. If you want to demystify more core concepts in data just like this one, do us a favor and hit that subscribe button. Thanks so much for watching.